topic flow control, the subject computer networks. Okay. So what is flow control? So in computer networks, flow control actually it is the process of managing the rate of data transmission between two nodes to prevent a fast sender from overwhelming a slow receiver. Okay, that means that the sender side and the receiver side, both the side, the speed of data transmission should be matched. Then only both can able to follow the same speed. Okay, so suppose sender is sending the data, too much of data, that is sender is sending too fastly, but the receiver is not able to receive in that much speed, so automatically the work will be slowed down, right? So at last, so some of the data may be lost. So due to low speed of the receiver, right? So flow control means the two persons, that is the sender and receiver, both the side, the speed should be matched. Okay, then only they can transmit the data smoothly. So that is called as a flow control. Okay, so it is the process of managing the rate of data transmission between two nodes to prevent a fast sender from overwhelming a slow receiver. In this flow control, so we can classify into two types. One is for noiseless channel and another one is for noisy channel. So in noiseless channel is two classifications are there. Simplest protocol and stop and wait protocol. Okay, simplest protocol and stop and wait protocol. In for noisy channel, three classifications are there: stop and wait ARQ, go back N ARQ, selective repeat ARQ. Okay, so for noiseless channel, simplest and stop and wait. So we'll discuss first about the simplest and stop and wait protocol, noiseless channel. First, simplest protocol. It's a very simple protocol. So you can see in this diagram, the sender A start to transmit the data. Actually, sender is sending the frame to the receiver. Okay, sender A, receiver B. In this diagram, we can see that. So sender A send the data to receiver frame. Okay, that is the data, first packet, first frame. And then the receiver is whether the receiver receiving the data or not, because the receiver won't send the acknowledgement. Okay, so then the sender, after sending the first frame, sender is sending the second frame. Okay, next sender is sending the third frame. Like that, how many packets is there? All the packets are sent by the sender to the receiver. Okay, so note down that. So it is called as a simplest protocol. So simplest protocol means just a sender send the packet to the receiver, and the receiver won't send any reply or acknowledgement. Senders simply keep on sending the data without any getting reply from the receiver. Okay, so that is called simplest protocol. So it is very when it will be used means only small amount of data is there to transmit, means we can prefer simplest protocol. Okay, next stop and wait protocol. So you can see here stop and wait protocol. It is also one of the important protocol. So sender receiver both the side. At the side of sender, first sender has to send the frame to the receiver, right? So the receiver receiving the frame, and he has to send an acknowledgement to the sender. Okay, first sender has to send a frame to the receiver. Then after receiving the frame, the receiver has to send an acknowledgement to the sender. After receiving acknowledgement, now you can see in this diagram, sender is sending the next frame. Okay, so now after the receiver is receiving the second frame, now he is sending an acknowledgement to the sender. So like that, it will be process how many packets are there. All the packets will be sent like in this format only in stop and wait protocol. Okay, so in stop and wait. Okay. Okay, now, so the sender send the data for that is packet to the receiver. Receiver sending and sender sends an acknowledgement to the sender. Okay, after receiving the data, he will send an acknowledgement. Okay, this is called as a stop and wait protocol. So it is also one of the simplest protocol. That is, whenever the amount of data is so small, in that time we can prefer stop and wait protocol. So what's the difference between simplest protocol and the stop and wait protocol? Means in simplest protocol, so we won't receive the acknowledgement, right? Without getting the acknowledgement, you are sending the data, right? So, but we don't know whether the data is received by the receiver or not, right? So that is the main drawback in simplest protocol. But in stop and wait protocol, you can see that. So if you receive the acknowledgement, you can feel that safely. Okay, okay, the data is received by the data is received by the receiver. Okay, so for small amount of data, you can prefer stop and wait protocol. Okay. So these are the two classifications of noiseless channel, simplest and stop and wait protocol. Next, for noisy channel, another classification, that is stop and wait ARQ. For noisy channel, you can see that stop and wait ARQ, go back in ARQ, selective repeat ARQ. So these three classifications are there, right? So stop and wait ARQ, go back in automatic repeat request, selective repeat, automatic repeat request. Okay. So now we will discuss about this topic. So can you able to hear? Students, can you able to hear me?
Yes, ma'am.
Okay, okay. Okay, now, so in that stop and wait protocol, it is classified into four types. Uh, that is, first one is stop and wait normal operation, stop and wait ARQ, comma last frame, that is automatic repeat request. Okay, ARQ means automatic repeat request. Next, stop and wait ARQ last acknowledgement frame, stop and wait delayed acknowledgement frame. Okay, so that is first one is normal. Now we have discussed about that stop and wait protocol operation, right? So that is called as a stop and wait normal operation. Next one, stop and wait ARQ last frame. Okay, is that we are going to discuss now. Okay, you can see here. The first one, just what we have discussed in the previous slide, that is the same thing only here it is. It is stop and wait protocol. That is sender send the first frame to the receiver. Then the receiver is sending acknowledgement. Now the sender is sending the second frame. Now the receiver is receiving the acknowledgement. Okay, like that it will be uh, proceed the remaining packets also. Okay, next stop and wait ARQ last frame. Okay, stop and wait ARQ last frame. That means when the sender send the packet, that means frames to the receiver, in that time the frame itself sometimes it may be lost, right? Yeah, so due to some problem, the frame may be lost. So what will happen in that time? So that only we are going to discuss here. In this slide, you can see that now first the sender is sending the packet to the receiver, that is the frame 0. After that, after receiving the frame 0, now the receiver is sending an acknowledgement to the sender. Okay, now the sender is sending the next frame. So in this time, you can see in this diagram, frame 1 is lost, right? Frame 1 is lost. So what happens? So the receiver won't send the acknowledgement because frame 1 is lost. So receiver won't send the acknowledgement. So that's why sender can understand that, okay, that is the frame 1 is not received by the receiver. So that we have to resend the frame 1. Okay, now you know the importance of acknowledgement, right? So acknowledgement, so without acknowledgement, we can't expect, that is, we can't think that whether the data is received by the receiver or not, right? Now the frame 1 is lost, so it won't receive the acknowledgement. So what happens? Sender is sending the frame 1 again to the receiver. So receiver is receive now so in the second one you can see that frame one received by the receiver. So receiver is sending the acknowledgement to the sender. So you can see that actually acknowledgement 1, acknowledgement 0. Actually acknowledge here it will denote in stop and wait protocol. So the acknowledgement number or frame numbers are only denoted in binary format only 0 and 1s. Okay, so it won't indicate that in decimal numbers 1 to 2 3 4 like. So only it indicates that 0s and 1 only. Okay, that's why it is indicated 0 1. Okay, now it receives after receiving the frame 1, now it receives the acknowledgement. Okay, that is called stop and wait AR to last frame. Next one, stop and wait last acknowledgement frame. So it is also similar to that only. Okay, so that is first we lost that packet, that is frame, right? Here in this diagram you can see that the last acknowledgement frame. Okay, acknowledgement itself lost. So in this diagram, first sender is sending the frame 0 to the receiver. Now the receiver is receiving the acknowledgement frame, and his receiver is sending an acknowledgement to the sender. Now the sender is sending frame 1. Okay, next frame. Now in the meantime, a receiver receives the frame, and if receiver send the acknowledgement. Okay, when he send the acknowledgement, okay, it transmitting the acknowledgement. In that time itself, acknowledgement is lost. Okay, so when the acknowledgement is lost, so sender won't receive the acknowledgement. Okay, so in this diagram you can see that acknowledgement is lost, right? So what happens, sender won't receive the acknowledgement, so it has to resend the same frame because still it has not received the acknowledgement. Okay, now it resend the frame 1 to the receiver. Now receiver receiving that frame 1. Okay, so now after receiving that frame 1, it send the acknowledgement. Okay, that's all. So stop and wait last acknowledgement frame. Okay, so in the stop and wait protocol itself we are discussing about so many classifications, right? So that is first one is delayed, that is last frame. Now the second one is last acknowledgement frame. Acknowledgement is last, so that what will happen, so if it is acknowledgement is last means, okay, sender won't receive the acknowledgement, so that it is resending the same frame again. Okay, after receiving the acknowledgement, okay, send the next frame. Okay, like that it will send the packets. Next delayed acknowledgement frame. Stop and wait delayed acknowledgement frame. So here you can see that the sender that is delayed acknowledgement frame. So delayed acknowledgement frame is actually uh, whenever you send the data or acknowledgement, so some particular time period will be there. Okay, so within the particular time period it has to receive the data, whether it may be a data means frame or acknowledgement, whatever it may be. So here you can see that it is mentioned as timeout, right? So that is within the particular time period it has to receive. So that is the thing, right? So if it is not receiving the data within the particular time period, then it is called as a delayed frame. Okay, so like that, if the acknowledgement is not received within the particular time period, then it is called as a delayed acknowledgement frame. Okay, so now you understand the concept, right? Now we can discuss. You can see in this diagram example. So sender send the frame 0 to the receiver. Sender send the frame 0 to the receiver. Receiver send the acknowledgement. So what happens? So the acknowledgement is not received by the sender within the particular time period. It is mentioned as time out. So, okay, for example, so it may be fixed. Okay, so within the 1 second or 2 seconds, it has to receive the acknowledgement. Okay, the time is fixed for acknowledgement, receiving the acknowledgement or receiving the data. So reply. So now the time period, within the time period, okay, it has not received the acknowledgement. So you can see here. So timeout. So it is mentioned as delayed acknowledgement frame. So sender thinks that the receiver has not sent the acknowledgement. So what happens? It anyway, whether it may be lost or delayed, the sender has not received that acknowledgement, right? So resend the same frame to the receiver again. Okay, so sender frame 0 is resend by the sender to the receiver. So now you can understand that. Now receiver is actually see at the other side of receiver, expecting frame 1. You can see in the diagram. that is yellow color, it is mentioned that expecting frame 1. Why it is mentioned as expecting frame 1 and frame 0 is discarded means already the frame 0 is received, right? Frame 0 is received by the receiver, but the acknowledgement is delayed to the sender, right? That's why I have received that frame 0. Then the next frame only I'm expecting, that is frame 1 only I'm going to expect, right? That's why it is expecting frame 1, okay, not frame 0. But at the sender side, that acknowledgement is delayed, right? That acknowledgement is not received in the particular time period, so that it resend the frame 0. Okay, but here expect that is the receiver side frame 0, if it receives also frame 0 will be discarded, because that is already the frame 0 already it receives it received by the receiver, right? Okay, so now after later, that is this at the sender side you can see that now acknowledgement one is received, right? Okay, after receiving that acknowledgement 1, okay, now it's in the frame 1. Okay, so like that it will be resend the data. Okay, that is if it is delayed also, the frame Z, that is if the acknowledgement is delayed or the frame is also delayed. Okay, sometimes the frame is also delayed within the particular time period, the particular time period it has not received, then what happens, it has to resend the data. But the thing is already maybe the receiver received the frame, so it won't receive the same frame again, because already it is available in the memory, right? So this is, it is called as a stop and wait delayed acknowledgement frame. Stop and wait delayed acknowledgement frame. Okay, so that's all about stop and wait protocol. So stop and wait protocol, so we have discussed about two types of protocol, three types of the protocols, that is stop and wait ARQ, last acknowledgement frame, and stop and wait ARQ, last frame itself last, and stop and wait protocol, that is ARQ, delayed acknowledgement frame. Okay, so these are the classifications of stop and wait. Next, so disadvantages of stop and wait. Disadvantages of stop and wait. So what are the disadvantages? So disadvantages means actually if it is a small amount of data you need to transmit, means it is easy to transmit the data by using stop and wait protocol, because whenever if it is a bulk amount of data means it is very difficult by using this stop and wait protocol. For example, if you need 1,000 packets to transmit, it's very difficult, right? That is, you have to send each and every packet, you have to wait for an acknowledgement, right? So it is really, it will take too much of time, right? So that is, first you have to send the data and you have to wait for an acknowledgement. After receiving the acknowledgement, you have to send the second data. So in the meantime, sometimes the packet may be lost, or the acknowledgement may be lost, or packet may be delayed, so that you have to resend. So many problems are there, right? So these up to 1,000 packets, you have to wait for the too much of time period, right? So it will be suits only for if it is a small amount of data, small amount of packets, means you can prefer stop and wait protocol. But if it is bulk amount of data, means you can't use the stop and wait protocol. You can use, but it will take too much of time, right? So too much of time it will take, so that we will go for the next frame. Okay. So next one, actually another one, the go back NARQ, selective repeat request here. Okay, so two classifications are there. So first we will discuss about go back NARQ. So here you can see that yes LSF, that is the window size. Actually, before sending the, here we won't send the data we won't send single frame. Okay, that means on window size will be fixed. So that is window size may be 3, 5 or 10, depends, right? So first the window size should be fixed. So in that window, if we fix 3 frames at a time, we can send. Okay, so then sender can send 3 packets continuously without expecting acknowledgement. Okay, so once again I will tell you, that is in this go back in ARQ and selective repeat, actually first the window size will be fixed. Okay, window size Actually, this another name of these protocols we call as sliding window protocol. Okay, sliding window protocol. So for an example of sliding window protocols only, go back in ARQ, selective repeat request ARQ. Okay, so now in this sliding window protocol, so the window size is fixed. Suppose the window size is 5. Okay, assume that window size is 5. So then the sender can transmit 5 packets at a time without expecting the acknowledgement. Okay, without expecting the acknowledgement. So that is the thing here. Okay, so after sending 5 packets, it can expect for acknowledgement. After receiving 5 acknowledgements, then it can send the remaining packets. Okay, so remaining packets also like that 5 packets. Okay, the window size is fixed, right? So it may be that is a 5 or 10 depends upon that. Sender can fix the window size based on the receiver's capacity. Both can decide the window size. Okay. In the meantime, also the receiver can send the acknowledgement or may not. Okay. So, for example, the window size 5 means first packet is sent by the sender to the receiver. The receiver can send an acknowledgement immediately. Okay. First frame 0 itself, it can send an acknowledgement, or frame after sending frame 1 also it can send an acknowledgement, or after sending 5 frames also the receiver can send an acknowledgement. So the concept here is based on the window size, it send the acknowledgement. That is, after 5 packets, the receiver can send the acknowledgement. No need to wait for each and every frame. After sending each and every frame, no need to wait for an acknowledgement. Okay, that is the thing here. Okay, now the sender in this diagram, you can see that the sender first sending the window size is fixed as 3. Okay, 0, 1, 2. Okay, so first is frame 0 is sent by the sender to the receiver. Okay, next, the receiver won't send, the receiver has not sent the acknowledgement. Now the sender is sending the frame 1. Okay, now the receiver is sending acknowledgement 2. Why it is sending acknowledgement 2? Because frame 0, frame 1, both it receives. Okay, that's why it is sending acknowledgement. That is cumulative acknowledgement. Okay, here it may be digital numbers. That is the decimal numbers can be, that is 1, 2, 3, up to any number can be used by the sliding window protocol, but in stop and wait only binary numbers are used. Okay, now frame 0 sent, it won't send the acknowledgement. Now the sender is sending frame 1 to the receiver. Now the receiver is sending acknowledgement 2. That means both the frame 0, frame 1, both frame received by the receiver. That's why it is sending acknowledgement 2. Cumulative acknowledgement is sent. Next, sometimes suppose the 3 packets are there, means okay, the next 0, frame 0, frame 1, frame 2. So after receiving the frame 2, the receiver can send the acknowledgement 3 also. Okay, so without sending acknowledgement 2, it may directly send the acknowledgement 3. Okay, that is also correct only. Okay, so like that it send the packet. Okay, so okay, from frame 2, after sending frame 2, now the receiver is sending acknowledgement 3. Now the window size, first window is over, right? Now it has to fix the next window. Okay, remaining next is for 0, 1, 2, next 3, 4, 5. Okay, like that remaining packets, the remaining frames can be sent by the sender. Then the receiver is also will send the acknowledgement in this format. Okay, so that is called go back in ARQ. So in this go back in ARQ also, the frame may be lost or acknowledgement may be lost, right? So in this, I can see in this diagram, the frame is lost, right? Frame 2 is lost. The first frame 0 is sent to the receiver. The receiver won't send the acknowledgement. Frame 1 is sent to the receiver. Now acknowledgement 2 received by the sender. Now sender is sending frame 2. So you can see here frame 2 is lost in the diagram. I can see that frame 2 is lost, right? Frame 2 is lost. So what happens? Frame 2 is lost, right? Now the sender is sending frame 3. So note down that frame is the window size is 3. So frame 0, frame 1, frame 2. So frame 2, when it sends the frame 2, it lost the frame, right? The receiver not receives the frame 2. Now, so now sender is sending frame 3. So receiver won't send the acknowledgement of the frame 3 because it discard that frame 3. Uh, Still the receiver has not received the frame 2. So okay, after receiving the frame 2 only, it will accept the next frame, okay, frame 3. So until receiving the frame 2, it won't send the acknowledgement. Whatever the frame you sent, all the packets will be discarded. All the frames will be discarded by the receiver. Okay, now you can see here frame 3. If sender sending the frame 3, then now the receiver discard the packet, right? Again, then the sender can understand that, okay, frame 2 is not received by the receiver. That's why the frame 3 is lost, discarded. Okay, now again the frame 2 is resent by the sender to the receiver. Okay, now after receiving the frame 2, the receiver send the acknowledgement 3. Okay, so that the thing is, so here also it cumulative acknowledgement it can send, but whenever the frame is lost, the particular frame is lost means, so if you send the next frame also, it won't receive, it will discard the packet, and then the sender has to understand that, okay, the previous frame is not received by the receiver, so we have to resend the frame. When you resend the frame, then it is send the acknowledgement. Okay, so that is called as go back in ARQ last frame. Here also that is lost, it may be the frame may be lost, here the acknowledgement may be lost. Okay, the same problems can be applied here also. Next, selective repeat ARQ. Okay, selective repeat ARQ. So it is also one kind of method in sliding window protocol. See, here also the same format, that is the window is fixed. It may be the window size may be 2, 3, 4, 5, 10, whatever it may be. Here the thing is, see, in this go back in ARQ, suppose the frame 2 is lost, okay, or frame 3 is lost. Which number of frame is lost? So when it lost means you have to resend, that is all the frames until suppose frame 3 is lost means again you have to send frame 0, frame 1, frame 2, frame 3. Okay, so that is a drawback here. Go back in ARQ. Which number it lost? So up to that number you have to resend it. Okay, that is a drawback in go back in ARQ. But in selective repeat ARQ, only which packet is lost, that packet may be resent to that receiver. Okay, so that is here you can see frame 0 is sent by the sender and frame 1 is sent by the sender to the receiver. Now receiver is sending the acknowledgement 2. Now again that is a frame 2 is lost. Frame 2 is lost, but the sender doesn't know that the frame 2 is lost or not. But now the sender is sending frame 3. Now at the side receiver, the frame 2 is lost, right? So it won't receive that frame 2, right? So that it send the signal negative acknowledgement. Okay, so NAK, that is the full form of NAK means negative acknowledgement. Okay, it send the negative acknowledgement to the center. Okay, so now you can understand that that is only the frame 2 is lost. That's why a negative acknowledgement, that the frame number 2 is mentioned here. Negative acknowledgement 2 is sent to the center. Okay, now after receiving the negative acknowledgement, the sender can understand that, okay, frame 2 is lost. Okay, so we have to resend the frame 2. Okay, now it resend the frame. That's all. After resending the frame, receiver receives that. Okay, after that, the next packet will be, that is a frame 3 will be sent from the sender to the receiver. Okay, the same process will be repeated. Here only the concept is which packet is lost. That is called, it is called as a selective repeat ARQ. That is which packet is lost. So then it, the receiver send the acknowledgement of, that is negative acknowledgement of the particular frame. Okay, now receiving this negative acknowledgement, sender can understand that we have to resend the frame once again. Okay, now it will resend it. That's all about flow control. Okay. Once again, we will summarize the topic. Okay, that is first flow control definition. Next classification, noiseless channel and noisy channel. Noiseless channel, two classifications are there. One is simplest protocol and another one is stop and wait protocol. And for noisy channel, three classifications are there: stop and wait ARQ, go back in ARQ, next selective repeat ARQ. Okay. Next simplest protocol, the sender send the data to the receiver, but receiver won't send the acknowledgement. Okay, only sender keep on sending the data to the receiver without expecting the acknowledgement. Next stop and wait protocol, sender send the data to the receiver, receiver send the acknowledgement. Okay, so like that it will say keep on sending the data from the sender side, receiver will send the acknowledgement. But only the thing, it will be suitable for a small amount of data are there to transmit this, we can prefer this stop and wait protocol. So in this stop and wait protocol itself, three classifications are there. Actually, stop and wait automatic repeat request, and sorry, noisy channel, three classification. Go back n, another one. Go back n automatic repeat request. Selective repeat automatic repeat request. Okay, these two go back n selective repeat, and they are the example of sliding window protocol. Okay. Next, in this stop and wait protocol itself, three now only first one is normal operation. Next, three classifications are there: stop and wait ARQ last frame, stop and wait ARQ last acknowledgement frame, stop and wait delayed acknowledgement frame. Okay. So stop and wait. First stop and wait. It is a sender. The same thing only. Sender send the data to the receiver. Receiver send the acknowledgement. Sender send the data, and receiver. This process will be repeated to all the packets, right? Stop and wait ARQ last frame is, that is, if the frame is lost, it may be that is it has to resend the frame. That is, the frame is lost means the receiver won't send the acknowledgement, so it has to resend. After receiving the frame, then the receiver will send the acknowledgement. Okay. Next, so similar way, if the acknowledgement is lost means also, so it has to resend the acknowledgement. Next, delayed acknowledgement. Delayed acknowledgement means that is within the particular time period, it has to receive the acknowledgement. Okay, so within the particular time period it is not received means it is considered as delayed. Okay, so that it has to once again resend the acknowledgement. After resending the acknowledgement only, the sender will send the next packet. Okay, so disadvantages of stop and wait protocol is it won't suits for bulk amount of data transmission. If it is amount of data is small, it will be easy to transmit the data by using this stop and wait protocol. Okay, if bulk amount of data is there means we can prefer sliding window protocol. Here the two uh, types are there. One is go back in ARQ, another one is selective repeat ARQ. Okay, so go back ARQ, selective repeat ARQ. So here window size is fixed, then the based on the window size. Okay, suppose the window size is 10 means, so you can send 10 packets continuously without expecting acknowledgement. Okay, so in the meantime, that is the receiver may send an acknowledgement or may not send an acknowledgement. It may send cumulatively after the receiving 10 packets also, it can send an acknowledgement. Okay, otherwise in between, okay, after the receiving frame 5 itself also, it can transmit the acknowledgement. It may or may not, but after cumulatively it can send the acknowledgement. Cumulative number, it can send the acknowledgement. Okay, next is selective repeat also. So in the selective repeat, so only negative acknowledgement signal will be sent to the center by the receiver when the frame is lost. Okay, then the sender can understand that okay, the particular packet is lost, so we have to resend it. Okay, that's all about flow control. Next, error control. Actually, error control includes both error detection and error correction. Okay, error detection and error correction. So it allows the receiver to inform the sender if a frame is lost. Sometimes the frame may be lost or it may be damaged during the transmission, right? So that is a transmission and coordinates the retransmission of those frames by the sender. So error control in the data link layer is based on, so we have discussed in this OSI model, that is error control. That is the responsibilities of data link layer is called as an error. One of the one of the responsibilities error control, right? Okay, is based on the automatic repeat request. So whenever an error is detected, its specified frames are retransmitted. Okay, So error types. So three types of errors are there. One is single bit error, another one is multiple bit error, another one is burst error. Okay, single bit error, multiple bit error, burst error. Single bit error. Actually, sender is sending the data to the receiver. It will be denoted in the binary form, right? The zeros and ones, right? So in this diagram, you can see that yellow color it is highlighted. Senders the data, that is one of the bit is changed at the receiver side 1. Okay, that is 0 is changed to 1, right? So sometimes 1 may be changed to 0 or 0 may be changed to 1. Okay, that is called single bit error. That is only one bit is changed. Okay, one bit is changed to changed at the receiver side. Okay, that is 0 may be changed to 1 or 1 may be changed to 0. So that is called single bit error. So multiple bit errors. Okay. Multiple bit error means that is two or more errors. Okay, that is two or more bits are corrupted. Then it is called as a multiple bit error. Two or more errors are bits are corrupted means then it is called as a multiple bit error. So in this diagram you can see that two bits are corrupted. So first the second one, that is one is converted to 0, right? Then third, fourth, the fifth one, fifth bit also corrupted. That is 0 is converted to 1. So two errors are there, right? Two or more. Okay, so sometimes three errors, three bits are more, four bits are 5 bits. So two or more bits are corrupted. Then it is called as a multiple bit error. Okay. Next, burst error. Burst error means continuously. That is in this diagram. So first, that is center side. You can see that fourth bit, fourth, fifth, sixth, seventh, eighth. So the all these bits are continuously corrupted, right? So continuously, if it is corrupted, means that is zeros are converted to one, zero is converted to one. Next bit one is converted to zero, and again two zeros are converted to one. So it is continuously. If the bits are corrupted, means then it is called as a burst error. Okay. So that's the types of error. Okay. So types of error, three types of errors are there. Single bit error, multiple bit error, burst error. Okay. Okay. Next, error control mechanisms. Actually, one is detect and how to detect the error, and another one is how to correct the error. Okay. So error detection. So three mechanisms are there: two-dimensionality parity, and another one is checksum. Another one is cyclic redundant check. Next, error correction, Hamming code. Okay, two-dimensional parity checking, checksum, cyclic redundancy check. Okay, these are the mechanisms only used to identify the error. It won't correct the error. If it is, for example, in the single bit error, multiple bit error, you can see that the bits are corrupted, right? That will be identified by these types of mechanisms. Okay, it won't be corrected only. It will identify that okay, these are the bits are corrupted, like that. It will identify that error correction. Then how to correct that error? That for that we are using the mechanism Hamming code. Okay, okay, that's all. So the topic is over. Now we'll move on to that question session. So, so you can try to give the answer, right? Okay, first question. ARQ stands for, I told the full form, right? Anyone? Can you give me the answer? ARQ stands for, I told the full form. Yes. In the slide itself, so many times in the stop and wait ARQ last frame. Stop and wait ARQ acknowledgement frame. What's the full form of ARQ? Anybody? If you're saying mistake, also no problem. Just to try to say the answer. Yes. Can you hear me? Are you able to hear?
Yes, ma'am.
Yes. Anyone? Can you say the answer for ARQ full form? If it is wrong, also no problem. Just to try to say something.
Ma'am,
Yes.
automatic repeat
Uh,
request, ma'am.
very good. Automatic repeat request.
Request.
Very good. Very good. Correct only. Okay, you are correct. Automatic repeat request. Okay. So the D option D is the correct answer. Next question. Okay. Can you say the answer? Stop and wait ARQ is a special case of go back in ARQ in which the size of the sender window is. Yes. So listen the class easily you can give the answer. See, stop and wait
One, ma'am.
ARQ. One. Very good. Very good.
Ma'am,
One.
two, ma'am.
Not two, pa. The stop and wait ARQ. Actually, stop and wait protocol. What is the size of window in stop and wait ARQ? Stop. See, we have discussed about two types. One is stop and wait, and another one is that is sliding window. In that sliding window only, I told that go back in ARQ and selective repeat and also on so right. But stop and wait protocol, you can see that only one packet only we are sending. Okay, so I told in the drawback also I told you that is first packet is sent, the receiver has to send the acknowledgement. Then after receiving the acknowledgement, then the sender has to send the second acknowledgement, right? So receiver has to send the second packet, right? So stop and wait. So you have to. It will be very useful in these topics and all. It will be very useful to you. See, stop and wait protocol only that is window size is one because we are sending only one frame at a time. Okay, but in go back NARQ or selective repeat ARQ, we go to fix the window size. Okay, window size may be vary more than two or more than two. But in stop and wait, only one. Okay, so otherwise, now I'll show you in this diagram, you can see that. See stop and wait protocol, right? First, it send the data, and then it send an acknowledgement. It send the data, it send the acknowledgement, okay?
Okay, ma'am.
Here, okay, you can see here clearly. See, one packet it is sending, then acknowledgement is receiving by the center, received by the center. See stop and wait ARQ also the same thing. Okay, last frame or the last acknowledgement delayed, whatever it may be, stop and wait means immediately you have to remember that only one packet. But in go back in or selective repeat depends. Okay, the window size may be vary, but minimum size is two. Maximum any number can be fixed. Okay, so very good. Second question answer is one. Stop and wait protocol means immediately you go to say that the window size is one. Okay, fine. Next question. In the protocol, in the dash protocol, the sender sends one frame, stops until it receives confirmation from the receiver, and then sends the next frame. Third question. Anybody? So you can take 2 minutes time also, no problem. Yes. Anybody knows the answer? You can give me the answer. Simplest protocol, stop and wait protocol, selective repeat. So we have discussed only four protocols, right? So the four protocols given here. So which protocol is the answer? Yes. Third question. Yes, anybody? It's very simple. Just now also I told the answer, same answer in the previous question.
Stop and wait.
Which one, ma?
Stop and wait, ma'am.
Okay, very good. Stop and wait. That is the correct answer only. Okay, it's a simple question only because see in the stop and wait protocol, the sender sends one frame and stops until it receives the confirmation. Confirmation means acknowledgement from the receiver, right? And then it sends the next frame. Okay, after receiving the acknowledgement only, it sends the acknowledgement. Sorry, next frame. Okay, so that is the thing. Stop and wait protocol. Okay, very good. That is the correct answer. Okay, next question. Okay, next, can you give me this answer for this question? In the dash protocol, we avoid unnecessary transmission by sending only frames that are corrupted. This answer also I have explained
Go
clearly.
back.
Which one? Which one? Yes.
What option, ma'am?
Option. Which option you are saying?
C.
C. Yeah. Which one you are saying? A or C? Which one you are saying?
C, ma'am.
D.
C.
D. You are saying D, right? No, I couldn't
Go back
hear.
and yeah, ma'am.
See, you are saying, okay, go back in ARQ. See, actually, I told you that in go back in ARQ, suppose if any packet is missed, means it has to retransmit all the packets up to that number, right? So I told the difference, but in selective repeat request, selective repeat ARQ, only which packet is corrupted, that packet only we have to transmit. Only we can transmit the particular packet. Okay, so the answer is selective repeat ARQ because see here the question is in the dash protocol we avoid unnecessary transmission by sending only frames that are corrupted. Okay, and the only corrupted frames only we have to transmit. No need to transmit unnecessarily all the packets. Okay, so go back in ARQ. Suppose third packet is lost means so first up to third packet we have to send. But selective repeat ARQ only the particular packet that is third packet is lost means we have to send only the particular packet, right? So negative acknowledgement told you that the NACK negative acknowledgement of the particular packet. So it then the sender can understand that only the packet that packet will be transmitted to the receiver. Okay, so the answer is okay. Good try only. Very good. Selective repeat ARQ is the correct answer. Okay. Next one. Yes. Anybody? Task control in the data link layer is based on automatic repeat request, which is the retransmission of data. So, it's very simple. Anyone?
Error control, ma'am.
Not error control, flow control. We are discussing about flow control only. We have discussed about flow control, right? Error control, okay, error control is also one of the responsibilities of data link layer only. But the thing is, here they have given that question automatic repeat request ARQ, selective repeat ARQ, stop and wait ARQ, go back in ARQ. Is it there? So automatic repeat request is available only in flow control, right? So flow control in flow is the correct answer. Okay, option A is the correct answer. Flow control in the data link layer is based on automatic repeat request. Okay, automatic repeat request means immediately you go to write flow control. Okay, so in error control and transmission control and all not suitable for that. Error, of course, error control is one of the responsibility, but here they have mentioned automatic repeat request, right? So that will be the answer of flow control. Okay, very good. Anyway, tried, right? Next. I have given the answer itself, I think. In the dash protocol, the sender send the frame one after another with no regard to the receiver. Okay, everyone knows that, right? Simplest protocol only. We won't expect for acknowledgement. Without expecting acknowledgement, we will send the data one by one, right? So, of course, the answer is simplest protocol. Okay, next, the dash protocol has, here also I have given the answer. Okay, the dash protocol has flow control but not error control. Okay, so stop and wait protocol has flow control. Here we won't have the error control. Okay, error control means, okay, we can control, but selective repeat ARQ and go back in ARQ. Some error control methods are used, but here we can't use that. Okay, next question. In the dash protocol, if no acknowledgement for a frame has arrived, we resend all outstanding frames. How can you, okay, which option is the correct answer? Yes. The dash protocol has flow control, but not dash error control. Sorry, next one. Can you tell me the answer here? Okay, if it is there also, you can give me the answer based on the question. Sometimes the option may be wrong or correct. Answer here. What's the answer here? In the dash protocol, if no acknowledgement for a frame has arrived, we resend all outstanding frames. See, one protocol, that is stop and wait to go back in ARQ, selective repeat ARQs. Out of these one frame I told you that is whenever the packet is lost, so it has to resend. That is, suppose the packet 3 is lost, so it has to resend all the frames. Okay, 1, 2, 3 up to the packets. Okay, all the packets it has to resend again. So which protocol I told you the concept? Yes. Anyone? Yes, pa. No one is saying the answer. Go back in ARQ is the correct answer, because go back in ARQ only I told you that the particular packet is lost, also it has to retransmit all the packets. Okay, all the packets again, that is 1, 2, 3. Suppose fifth packet is lost, means it has to send, that is fourth, that is 1, 2, 3, 4, 5. Okay, suppose the window size is 5, means it has to send all the packets again, resend the packet again. Okay, so that is the difference between go back in ARQ and selective repeat ARQ. Okay. And next question, the dash protocol has neither flow nor error control. Okay, anyone? Hmm. Seamless protocol. Okay, next one. Both go back in ARQ and selective repeat protocols uses dash. Sliding window. Okay, I told you that these two are the example of sliding window protocol, right? Both go back in ARQ and selective repeat protocols are the best examples for sliding window protocols, I told you, right? So option A is the correct answer. Next, the dash protocol adds a simple error control mechanism to the dash protocol. No one is there. Okay, this is the last question. Option C is the correct answer. Stop and wait ARQ. Stop and wait. Okay. So that's all about today's class. So any queries you can ask. Otherwise, we'll wind up the session. Okay, thank you. Thank you to all.